Hello everyone, welcome to Code2CloudX. So in the previous video, we discussed how applications are deployed. We started with physical servers, then moved to virtual machines and understood the role of a hypervisor. After that, we also discussed the limitations of virtualizations and how containerizations helps solve those problems. And finally, we briefly introduced Docker, which helps us containerize applications. Now we understood the basics of containerizations. So in today's video, we are going to understand the Docker architecture. So in this video, we will understand three important components, that is Docker client, Docker host, and Docker registry. And we will also see how these components work together to run containers. So before we jump into installing Docker, creating Docker images and running containers, it is very important to understand the internal architecture of Docker. So let's start with the first component of the Docker architecture, which is Docker client. So whenever we install Docker on our system, two main components are installed, Docker client and Docker server. So the Docker client is the interface through which we interact with Docker. So in simple words, we can say using the Docker client, we give instructions to Docker about what operations we want to perform, like build a Docker image, create a container from that image, start or stop a container, pull an image from Docker Hub. So all these operations are initiated through the Docker client. Now inside the Docker client, there are two main ways to communicate with the Docker server. First one is Docker CLI. So the first way is Docker CLI, which stands for command line interface. This is the most commonly used method by developers. So using Docker CLI, we can run commands like Docker build, Docker run, Docker pull, Docker start or stop. So if you have already worked with tools like Git CLI, AWS CLI, kubectl, Kubernetes CLI, so then Docker CLI will feel very similar to most developers use Docker CLI in their daily development and deployment process. The second way to communicate with Docker is the Docker Remote API. So using this API, applications and tools can interact with the Docker programmatically. How? So this is commonly used in CI/CD pipelines. For example, we have already used tools like Jenkins, GitLab CI, or GitHub Actions. We can use Docker Remote API to perform operations like to build Docker image, run containers, push image to a registry server, manage Docker environments automatically. For example, in GitLab CI, inside the .gitlab-ci.yml file, we can define jobs that run Docker commands. Similarly, in Jenkins pipelines, we can add Docker commands inside different stages. So instead of manually running Docker commands, CI/CD tools can automate the entire process using the Docker API. So this is how the Docker client communicate with Docker server. Now let us talk about the second major component of Docker architecture, which is Docker server. And also we can say Docker host. So as you can see in the diagram, when we install Docker on our system, two components are installed on the same machine, Docker client and Docker server. So the Docker client sends command and the Docker server is responsible for executing these commands. Inside the Docker server, there is a background service called the Docker Daemon, right? And you may have heard about Daemon thread in Java. Like A daemon thread runs in the background and provides service to other threads. Similarly, in Docker, the Docker daemon runs continuously in the background. So its main responsibility is to listen for commands coming from the Docker client. For example, commands like docker build, docker run, docker pull, docker push, docker start, docker stop. So whenever we execute any of these commands using the Docker CLI, the command is set to the Docker daemon, and the daemon processes the request and performs the required actions. So the Docker daemon is responsible for managing several Docker components like Docker image, Docker containers, Docker networks, Docker volumes. For example, when we run the command docker build, the command goes from Docker CLI to Docker daemon, and the daemon builds the Docker image, and then we run, and when we run docker run command, the daemon create and starts a container from that image. Okay. Now, if you can see, so a Docker image is basically a packaged version of an application. It contains everything required to run the application, such as application code, runtime environment, for example, Java or JRE, required libraries and dependencies, environment configuration, system jobs. For example, if we have a Spring Boot applications, the Docker image may include Spring Boot jar file, Java runtime, application configurations, required dependencies. All of these components are packaged together into a single Docker image. Got it? Once the image is created, we can create something called a Docker container, which is also the another components inside the Docker server. So a container is simply a running instance of a Docker image. Means image will be your blueprint and container will be your running applications. And we cannot create a container without first creating the image. Okay. So this is the application flow in Docker. You can read these lines which we discussed so far. So once the container starts running, we can call that endpoint and retrieve the user data from our applications. So essentially our microservices runs inside a Docker container. Now let us talk about the third important component of Docker architecture, which is called Docker Registry. A Docker registry is basically a repository where Docker images are stored and shared. Docker itself provides a public registry called Docker Hub. So using Docker Hub, we can store Docker images, share images with other developers, and download images whenever required. So, and we can also control access to these images. For example, we can make these images public or private. Apart from Docker Hub, many companies use their own private Docker registries. If we will give you some examples, we have GitHub Container Registry, AWS Elastic Container Registry, that is called ECR, Google Container Registry, GCR, Azure Container Registry, ACR. So most organizations prefer private registries because they provide better security, access control, easy integrations with cloud platforms. For example, if an organization is using AWS, so it makes sense to push Docker images to AWS ECR. Then during deployment, different environments like development, QA, pre-prod, prod can directly pull the same Docker image from AWS ECR and ensure that the exact same image is deployed across all environments, making the deployment process consistent and reliable. So in this video series, we will mainly use Docker Hub. And in the upcoming videos, I will show you step-by-step process how to create a Docker image, how to run a container from that image, and how to push an image to Docker Hub and how other systems can pull that image from Docker Hub. Okay, so now let us quickly understand the simple flow of what happens when we run a Docker command. Suppose we run a command using the Docker CLI. For example, you run Docker run my application. Okay, so here is what happens internally. First one, the Docker client sends the request to the Docker server, that is a Docker host. Okay, the Docker server checks whether the required Docker image is available locally or not. If the image is available locally, Docker directly uses that image. If the image is not available locally, Docker pulls the image from a remote registry such as Docker Hub. Once the image is available, Docker creates a container from that image and the application starts running inside that container. After that, we can access all applications through its REST API or microservices endpoints. So in Docker architecture, we have three main components: Docker client, which is used to send commands, Docker server or Docker host execute these commands, and Docker registry stores and distributes Docker images. So all these components work together to build, store, and run containerized applications. At the end, let us understand with an simple real world example. Suppose you want to run MySQL on our system. Earlier, the process was quite long, right? We had to go to MySQL website, download the installer, install MySQL, configure database, start the MySQL server, and this process could take a lot of time and configurations. But with Docker, the process becomes extremely simple. What we have to just run a command like Docker pull MySQL. Docker will download the MySQL image from Docker Hub. Then we will run Docker run MySQL. Firstly pull, then run. Docker will create a container and start the MySQL server inside that container. And within a few seconds, MySQL will be running on our system. So this is the power of Docker. And in our upcoming videos, we will also see how to run MySQL using Docker images. So now that we understand the Docker architecture and its component, in the next lecture, we will install Docker on our local system, create our first Docker image, run a Docker container, and push that image to Docker Hub. So make sure you follow the complete series. Thank you for watching, and I will see you in the next video. Thank you.